Good morning, students. Palkana Namaskar. So, in the last class, we were discussing about chapter Rotational Dynamics. Rotational Dynamics. In this, we were discussing about applications of circular motion. Circular motion चे दोन application पाहिले. A vehicle moving along a unbanked road or a road which is horizontal curve road. In this case, we have determined the maximum velocity of vehicle moving along the plane curve road given by mu s is equal to rg. Second application, a vehicle moving along a banked road. Banked road. In this case, we have determined the maximum velocity or velocity, safe velocity moving by the vehicle is given by rg tan theta. Also in this article we have derived the expression for angle of banking theta is equal to tan inverse of Vs square upon rg. Similarly, or also we have discussed the minimum velocity and maximum velocity of vehicle moving along banked road. So we have studied two applications. Let us study today a third application. The third application is well of depth. Well of depth. In Hindi it is called as मौत का कुआं. मौत का कुआं. आपल्याकडे जेव्हा मौत का कुआं, ठीक आहे, जास्त डिटेल मध्ये न जाता डायरेक्ट आपण डिस्कस करू. व्हॉट इज वेल ऑफ डेप्थ. मौत का कुआं म्हणजे काय? वेल ऑफ डेप्थ म्हणजे काय? इट इज अ vertical cylinder. It is a vertical cylinder. In this cylinder, vehicle or car, the person inside this cylinder performs stunts by two-wheeler or by car. Perform the stunts. Such a cylinder is called as well of depth, or in Hindi it is called as मौत का कुआं. In here what we are going to discuss. आपल्याला काय डिस्कस करायचे आहे मौत का कुआंमध्ये और वेल ऑफ डेप्थ मध्ये आपल्याला काय डिस्कस करायचे आहे. आपण पाहतोच नेहमीच कुठेही जेव्हा स्टंट पाहतोच त्यामध्ये एखादा व्हेकल असं गोल फिरत असतं तरी ते खाली पडत नाही. कार किंवा 2-4 व्हेकल असे गोल फिरत असतात. गोल फिरत असताना ते खाली पडू नये म्हणून त्याची काहीतरी मिनिमम वेलोसिटी असते. त्या वेलोसिटी पेक्षा कमी जर असेल तर तो जो व्हेकल आहे खाली येऊन आदळून पडतो आणि ऍक्सिडेंट होते. पण तो वेलोसिटी कशावर अवलंबून आहे आपल्याला पाहायचा आहे आणि त्याची एक्सप्रेशन काढायची आपल्याला. ते वेलोसिटी कशावर अवलंबून आहे आणि त्याची एक्सप्रेशन आपल्याला काढायची. सो इन द application of well of depth a vehicle is revolving in the well of death, we are going to determine the velocity, the minimum velocity with which a vehicle has to travel. If the velocity of vehicle is less than that minimum velocity, then it falls down, accident will take place. So for that, in order to determine minimum velocity, or on which factor it depends, let us discuss it. Let us consider a well of depth of radius r, or a cylindrical vertical cylinder of radius r. Let us suppose a vehicle is moving with velocity of mass m, moving with velocity v. Moving with velocity v. Let m be the mass of vehicle, v be the velocity of vehicle. And r be the radius of vertical cylinder or well of death. Usually नेहमी सांगत असतो मी, डेरिव्हेशन 3 टप्प्यातच असतो. पहिला टप्पा आहे डायग्राम डिस्क्रिप्शन, दूसरा टप्पा आहे फिजिक्स पार्ट, तिसरा टप्पा आहे डेरिव्हेशन आणि त्याच्यावर कंक्लुजन्स. पहिला टप्पा आपण कव्हर केला. Let us consider a well of depth of radius r. Let consider a vehicle of mass m moving with velocity v. How many forces are acting? Let us say how many forces are acting. Let us discuss one by one. Weight mg of vehicle is acting in downward direction, mg. Normal reaction. Reaction is always normal perpendicular to the body, which is equal to n. Is equal to n. Now, the friction between the tires of vehicle and wall of death acts always opposite to the mg. It is self-adjusting force. It acts in opposite direction. Hence, it is in vertical upward direction. Fs. So we have come to second point, that is forces. 3 forces are acting. Weight mg acting in downward direction. Normal reaction n perpendicular to the wall of the vertical wall of the depth. Force of static friction. We are calling it a static. Why? In vertical direction, vehicle should be stationary. It should be standing. It is moving in horizontal direction, but in vertical direction it is stationary. Therefore, we are considering the static friction Fs. As body is moving along horizontal direction, or it is performing circular motion in horizontal direction, the vertical forces should be balanced. Vertical forces should be balanced. Then only unbalanced force acts in horizontal direction, that is in the direction of normal reaction. Therefore, weight mg is equal to force of static friction Fs, or normal reaction n provides the centripetal force, or n is equal to centripetal force mass velocity v upon radius of depth wall, or r mv square upon r. So in order to obtain the final expression for velocity, again we have to think about the concept. Normal reaction depends upon velocity, mass and R. R is constant. M say let us M is constant, V is a constant. V is velocity. Here frictional force, static force of friction, the maximum or static force of friction Fs is less than or is equal to coefficient of static friction Fs into normal reaction. This we are studying in 11th standard. Force of static friction is always less than or equal to mu s into n. So this we have to consider on this factor. Or Fs is equal to Fs is less than or is equal to mu s into n. N is how much? M v square upon r. M v square upon r. And now Fs is equal to how much? Mg. Where is duster? Fs is equal to mg. We get mg is less than or equal to mu s m v square upon r. Get cancels, or g is less than or is equal to mu s v square upon r, or vs is equal to v square is greater than or is equal to rg upon mu s. rg upon mu s.